OK， let's check on. We try to discuss some probability. For example, we got several letters. What's the probability? What's the probability? This is several letters. We choose, select 2 out randomly. Hey, what's the probability? You got AS. And here, again, we choose 2 out randomly. What's the probability? We got AS. Jeffrey, 1. Okay, because we just choose 2 out. Total possible ways you choose 2 out. 8 C2. The top, if you choose AS, just 1 way. That's the probability. It's 1/24. 28. Oh,
that's all I got.
Okay. Tony used the other way. Check out. Tony used the other way. Tony said, oh, my denominator is 8P2. And the top, you could have AS or SA. So 2 ways. 2 out of 56. 1/28. Same answer. Same answer. Yeah, if you think about arrangement, you use this way, arrangement or permutation. If just selection, you use here, selection or combination. Okay. Number 2. What's the answer? Number 2. Okay, hey, still AS. Jeffrey, number 2.
Wait, for selections or arrangements?
Still AS.
Is this for selections or arrangements?
Let's check on. I'll show you a method and you tell me why it's not right. How many selections of choosing two letters? How many selections are choosing two letters? Case 1. We try. You choose two letters from here on. What's the total number? Case 1, just SS. Case 2, 1S. 1S, we have 6C1. Here, one way, 6 way. Case 3, no S. No S. No S, how many ways? 6C2, 15 ways. So total, if you just choose two letters out, we got 22 ways. Part B. How many selections? You got just AS. Just AS. Okay. How many selections you got just AS? Ayo, we got one way. Just one way. Now, guys, very important idea. This is 22 ways. This is one way. Can we say 1/22? Guys, can we say 1/22? Question 1. Question 2A. Question 2A, like you just select two letters from this word. It's called password. Possible ways you select two letters, 22 ways. And if you just select AS, just one way. So my question is, can we just write the probability 1/22?
Unfortunately, you have 2S, so there will be two possibility to get AS.
Someone said, oh, there are 2S on. We cannot write C. This is not right. This is not right. Why this is not right? Jeffrey, why it's not right?
Because you're doing probability, you have to. I think you have to assume for case 2.
Oh, I see why I cannot hear you. I probably connect to earphone.
Wait, hello?
Oh, yeah.
Hello.
Why we cannot write 1 over 22?
Is it because for case 2, the S you have to do selections for both S's? And then also for AS, there's 2 selections technically for probability because you have both S's.
Oh, good explanation. The key idea is these 22 ways not all equally likely. Not all equally likely. This one, the chance larger. This one got larger probability of 1s because there are 2s you can choose. Okay, there are 2s you can choose. That's why in this question, we need to pretend this 2s different. Actual answer for C. 2s is just different. So denominator 8C4, 8C2, you choose 2 letter out. But the numerator, A, just you don't need to choose, just 1. The chance you to choose S, you got 2. The chance to choose S, you got 2, which is 1 over 14 now. If you compare question 1 to question 2, question 2, the chance doubled. Because the chance you choose S doubled. Okay, this is not equally likely. That's why here not right. Okay. Now let's check a question from Jeffrey. A question from Jeffrey. This question. This question is from past paper. Check the question. We choose 4 letters from 8 letters. Tomorrow. Normally, I just write here. Hey, that's 8 letters, something repeated. We choose 4. As we just discussed. You have to treat those all like different. Otherwise, you cannot have equal probability, equally likely result outcomes. That's why denominator 8C4. Numerator. So many cases about numerator. 101R, 102R, 201R, 202R, 301R, 302R. Oh, we cannot 302R because in total just choose 4 out. No, this case. No, Check the numerator. How many ways? Choose O, 3C1. R, 2C1. This one give you 6. 3C1, 2C2 give you just 3. 3C2, 2C1, 6. 3C2, 2C2, 3. 3C3, 2C1, 2. Oh, in total, you know, 20 out of C4. Let's have a look. What's that? Oh, 2/7. 2/7? Jeffrey, what's the answer?
I think it should be in the photo. It's
4/7?
Wait.
Oh, in the photo, you mean?
Yeah, I think.
Oh, you mean
you
you got the answer already?
I was just asking why it's done differently for the 2 questions. Yeah, so it's 18 plus 9 plus 3 plus 2 plus 18, all over 70. So it's 5/7.
Oh, 5/7.
5/7.
We need double check.
Sam,
not finished. You need to
Yeah.
choose. You need to choose other one to make a 4. You need to choose from here, here, here to make 4 letters. 3C2 times by 3, 18. 18. This one you need to choose another one. So 3C1. This is 9. Yeah, we didn't finish choosing 4. This one is still 3C1. 18. This one already, okay. This one already. So in total, we got 18, 18, 36 plus 9, 45, 50, 5/7. Jeffrey, what's your question?
Oh, so you see how this one it's just because I didn't realize that some probabilities are more common than other ones. Like for the first one. That's
Okay.
why I wasn't sure how to do them.
I'll show you my method. This method, I also tried this method, but I think this method too complicated. So I think about another method. Guys, check out. If you need a probability at least 1 O and 1 R, that will be 1 minus probability, no O minus probability, no R, plus probability, no OR. Jeffrey, do you understand this working?
Yes,
Why I plus no OR?
because that's the overlap.
Yes, overlap. Because when you minus no O, you minus no R, you minus no OR twice. We plus. Now, Jeffrey, no O was the numerator. What's the numerator? No O.
5C4.
5C4. Good. What's the probability? No R, Jeffrey.
64.
What's the probability? No OR.
0.
Because you only got 3, you choose 4. That's not possible. Calculate the value. That's the answer. Jeffrey, understand this method?
Yes, thank you.
Okay, this is an annoying question.
Wait, Sam,
Yeah.
for integration, are we allowed to use inverse chain rule?
Allowed to use to what?
Inverse chain rule, or do we have to use substitution? So if you have brackets and you have to if you integrate brackets.
Substitution. It's in A2. I see. In AS, you only do this type of substitution. AX plus B. Integrate 1 over A something. You can use this. You don't have to use substitution.
Oh, I can use that? Okay, thank you.
Yeah. Yeah. Substitution is in A2 syllabus. Okay.
Because my teacher told me to just use the inside of the bracket and then make that another letter.
Okay. That's called substitution. That's what we learn in A2. Okay, you can do it. Okay. I hope you understand this question. Why we do this way? Yeah. Why we don't do here? Those were not equally likely. Those cases, SS and here equally likely. Okay. I mean, what 15 cases here equally likely. One case here equally likely. Like this is 15p. This is just 1p. But this 6 each is 2p. Because S, you got double chance to choose S. That's why in total you got the P, 12p, 15p, in total 28. Okay, this question. Okay, William X, understand this question? Let's check another question from William. Okay, another question pretty interesting from William is that one here. This one, guys. Here, car park. Impossible arrangement. We got 16 car parks. This one, just typical, you can say 16 P5 or 16 C5 times 5 factorial. Jeffrey, explain 16 I can use 16 C5 times 5 factorial. C5. Like you choose 5 car parks, spaces, and then arrange them. Okay, this example actually gave you the difference between P and C. If you don't arrange, just C. Okay, Question 2. Cars are not next to each other. Oh yeah, William X, did you check my answer? Is that correct? Okay. William X, what's the answer for the second part? Check on the number of possible arrangement for 5 cars, not next to each other in the car park. Oh, that means car, space, car, space like this, car, space, car, space, like here. Okay. William, what's the answer for II?
The answer is wrong.
Well, what's the answer?
It's 1,440.
1,440.
Yeah, but this
Okay.
is all 5 cars together, so it's wrong.
Oh, okay. I'll show you how I do this question. Because after arrange the cars in the car park, it's like 5 cars and after 11 empty spaces. Okay. Okay. It's very like you just arrange 5 cars and 11E empty space, 11E. So how you arrange them without car next to each other? Okay, we arrange those E's first. Oh, you don't need to arrange, they're all same. Now, this 11 spaces, you got 12 gaps. 12 gaps. Okay, so the question like, you got 12 gaps. How you arrange 5 cars? 12 P5. That's how I do this question. The answer is okay. William, do you understand my working? Because after you arrange empty space on the car, for example, you put car here, C1, C2, C3, maybe C4 here, okay, C5. It's really like, oh, you park car in the empty space. Okay. This question is hard. Number I is hard. Okay. Okay. Guys, another question. We need to double check transformation. Double check transformation. Those several questions we just discussed, pretty annoying.